It started as a routine sweep of the outer solar system, the kind astronomers had done countless times before. Just another slow search through the darkness beyond Neptune, where icy debris drifts quietly, and nothing ever seems to change. But buried in that data was a faint, distant point of light that didn't behave like the rest. It moved too slowly. It was too far away. And once scientists took a closer look, it became clear this wasn't just another frozen rock at the edge of the sun's influence. What they had found was an object so massive and so distant that it immediately raised an uncomfortable question no one was ready to answer. If this thing was real, and if the measurements were right, then Pluto might not be the oddball planet astronomers had debated for decades. It might be something even more unsettling. The discovery sent shockwaves through the scientific community, exposing long-standing cracks in how planets were defined, and forcing astronomers into heated, public disagreements. Behind closed doors, emergency discussions began. Definitions that had stood for generations were suddenly on the chopping block. But the chaos that followed wasn't just about science. This object would ignite one of the most emotional controversies in modern astronomy, dividing experts, confusing the public, and permanently changing how we talk about the solar system. And what makes the story even stranger is that this world, powerful enough to rewrite planetary history, was hiding in plain sight the entire time, nearly slipping past astronomers without anyone noticing at all. The object at the center of this story wasn't just distant. It existed in a realm of the solar system that most people never think about at all. Far beyond Neptune, beyond Pluto, and deep into the frozen outskirts known as the Kuiper Belt, this world traced an orbit so enormous that it shattered every expectation astronomers had for large bodies circling the sun. At its most distant point, it drifts nearly 10 billion miles away, so far that sunlight weakens to a faint, icy glow. Out there, the sun no longer dominates the sky. It's just another brilliant star, and a single orbit takes well over 500 years to complete. What truly unsettled scientists wasn't just the distance, but how extreme its path was. Unlike the relatively tidy orbits of the 8 planets, this object follows a wildly stretched trajectory, swinging from regions near Pluto's neighborhood to distances almost unimaginable. At its farthest, it travels nearly 3 times farther from the sun than Pluto ever does. That kind of orbit wasn't supposed to host something so large. Objects that massive were expected to have formed closer in, not lingering on the solar system's outermost edge like a forgotten relic. And yet, there it was, bigger than Pluto, heavier than anyone expected, and refusing to fit neatly into any existing category. This wasn't just another icy fragment mixed in with thousands of smaller Kuiper Belt objects. It stood apart, a gravitational heavyweight quietly circling the sun in near total darkness. Its very existence suggested that the outer solar system was far more complex and far more chaotic than the clean diagrams found in textbooks. As astronomers began to grasp just how unusual this object really was, a deeper unease set in. If something this large could remain hidden at such distances for so long, what did that say about our understanding of the solar system? And more importantly, how many other massive worlds might still be lurking beyond the limits of what we've already seen?
What makes this discovery genuinely unsettling is how easily it could have slipped past astronomers forever. When the first images were captured, nothing about the object seemed urgent. It didn't streak across the sky like an asteroid, or jump noticeably between frames the way most distant objects do. Instead, it crept along at a pace so slow that the automated detection systems, the same systems responsible for scanning billions of stars and galaxies, quietly dismissed it. To the computers, it looked almost stationary, just another meaningless speck in an ocean of light. For more than a year, that speck sat buried in archived data, completely overlooked. The images had already been processed, the search had already moved on, and no one realized that one of the most important objects ever found in the outer solar system was hiding right there, unnoticed. It wasn't until astronomers launched a special reanalysis of old observations, specifically targeting objects moving at extreme distances, that the anomaly finally resurfaced. When the data was revisited, the mistake became painfully clear. This wasn't a new discovery at all. It was a missed one. As soon as its motion was measured more carefully, everything changed. The object's sluggish drift suddenly made sense. Something that far from the sun wouldn't move quickly at all. And once its distance was calculated, its brightness became deeply troubling. An object that bright, at that distance,
couldn't be small. It had to be massive. Uncomfortably massive. That realization triggered a chain reaction. Astronomers scrambled to confirm what they were seeing, knowing that if the numbers held up, the implications would be enormous. This wasn't just another Kuiper Belt object quietly added to a growing list. It was a heavyweight discovery that had nearly been erased by a technical oversight. And as scientists rushed to understand what they had almost missed, a far bigger problem began to loom. Because if this object was truly as large as it appeared, it wouldn't just change what we knew about the outer solar system. It would force a reckoning with how planets themselves were defined. At first, the numbers didn't seem real. As astronomers refined their measurements, the object's brightness stood out immediately, far too bright for something sitting at such an extreme distance. That left only two possibilities. Either it was incredibly reflective, or it was enormous. And when early calculations began pointing toward the second option, the tension inside the scientific community spiked. If the estimates were even close to correct, this object wasn't just comparable to Pluto, it might actually be bigger. The idea alone was enough to cause panic. Pluto had already spent decades under scrutiny, its planetary status constantly questioned. But now, here was a new body, lurking far beyond it, threatening to upend the fragile balance astronomers had maintained for generations. If this object was larger than Pluto, then ignoring it wasn't an option. Either it would have to be called a planet, or Pluto's status would have to be reconsidered entirely. The problem was, no one could agree on the measurements. At such vast distances, size isn't something you can simply observe. All anyone could see was a point of light, and that light could be deceiving. A small, shiny object could appear just as bright as a massive, darker one. Teams around the world began racing to solve the mystery using indirect methods, analyzing heat emissions and reflected sunlight, each result carrying massive consequences. With every new estimate, the pressure grew. Some measurements suggested it was clearly larger than Pluto. Others hinted it might be slightly smaller, but far more reflective. Either way, the damage was already done. The mere possibility that a Pluto-sized or Pluto-beating object existed forced astronomers into an uncomfortable corner. Because no matter how the numbers settled, the question was unavoidable. If this world wasn't a planet, then what exactly was Pluto supposed to be? Once the discovery became widely known, the impact rippled far beyond the quiet halls of research observatories. Suddenly, astronomers were forced to confront a question that had long been simmering in the background. What actually qualifies as a planet? For decades, Pluto had occupied a curious, almost sentimental position in our understanding of the solar system. It was a planet in textbooks, a planet on maps, a planet in the collective imagination of generations. But this new, massive object lurking beyond Pluto made it impossible to ignore the inconsistencies in the definitions scientists had relied upon for so long. The debate quickly escalated into a full-blown spectacle. Conferences that were normally calm, technical affairs turned into heated arenas. Email chains buzzed with arguments and counter-arguments, each one dissecting not only the characteristics of the new object, but the very criteria used to define planets. Should size alone determine planetary status? Should orbit or composition matter? And most importantly, how could Pluto maintain its iconic title if this new world, almost certainly larger, almost certainly massive enough, remained in a separate, undefined category? The tension reached a breaking point at a highly charged meeting of the International Astronomical Union, where astronomers from across the globe gathered to finally settle the issue. The atmosphere was intense. Proposals were debated passionately, definitions were revised and attacked in rapid succession, and long-standing traditions clashed head-on with new discoveries. Some scientists argued fiercely that Pluto should remain a planet, and that this new object, temporarily nicknamed Xena, deserved the same recognition. Others countered that doing so would set a dangerous precedent, opening the door to dozens, perhaps hundreds, of similar distant objects suddenly qualifying as planets. After hours of heated discussion, the IAU arrived at a compromise, one that would leave a lasting mark on astronomical history. Instead of expanding the list of planets, they chose to redefine the term itself, narrowing the definition and drawing a clear line in the cosmic sand. The result? Pluto was demoted, along with the newly discovered world, which would instead be classified as a dwarf planet. To scientists, it was a practical solution to an impossible problem. But to the public, it felt like the loss of a familiar, cherished member of the solar system. Headlines screamed, debates raged online, and the argument spilled into classrooms and living rooms around the world. And at the center of all this controversy was Eris, the distant, icy body whose quiet journey through the outer solar system had upended our understanding of what it means to be a planet.
Its existence forced astronomers, scientists, and the general public alike to ask uncomfortable questions about classification, tradition, and the very way we define our cosmic neighborhood. For a frozen world so far away, it had already left a massive, unshakable footprint on human imagination and scientific debate. A footprint that would continue to stir arguments for decades to come.
What makes Eris even more extraordinary isn't just its size or its orbit, it's what lies on its surface. Unlike most distant objects in the Kuiper Belt, Eris doesn't resemble a dark, shadowy rock drifting aimlessly through space. Instead, it shines with an almost startling brightness, reflecting more sunlight than any other object in the solar system, except for Saturn's moon Enceladus. Observations from powerful telescopes like Gemini and Hubble revealed that its surface is almost uniformly white, coated with a layer of frozen methane, so pristine it seems untouched by time. This gleaming exterior tells a story of extremes. At Eris's current distance from the Sun, temperatures plunge to an unimaginable 405 degrees below zero Fahrenheit, so cold that its entire atmosphere has frozen solid onto the surface. What might have once been a mottled landscape of ice and rock is now blanketed in a thin, shining coat, preserving its brilliance across hundreds of millions of miles. The uniform whiteness is deceptive, though. It hides a complex, dynamic world that undergoes cycles unlike anything seen closer to home. Over the course of its 560-year orbit, Eris experiences temperature swings so dramatic they defy belief. As it moves closer to the Sun over the next 280 years, its surface will warm, and frozen methane and nitrogen will sublimate, creating a thin atmosphere. Then, as it drifts back to the outermost edges of the solar system, that atmosphere will freeze again, coating the planet in another layer of sparkling frost. In effect, Eris undergoes a slow, dramatic transformation that repeats every half millennium, making it a planet of extremes, cold beyond comprehension, yet capable of subtle, cyclical activity driven by the Sun's faint warmth. Even more fascinating, the similarities and differences with Pluto are striking. Both share a composition rich in ice and rock, and both display frozen methane on their surfaces. But while Pluto's surface is moderately red and mottled, Eris is almost ghostly white and remarkably uniform. Its reflective brilliance is unmatched, making it a standout not only in the Kuiper Belt, but across the entire solar system. Every measurement hints at a world that is alive in its own frozen way, a reminder that even at the edge of our solar system, extreme and mysterious phenomena continue to challenge our understanding. Beyond its surface, the story of Eris extends deep into its interior and its relationship with its tiny moon, Dysnomia. While we can't see inside the dwarf planet, scientists have strong clues about what it's made of. Like Pluto, Eris is likely a mix of ice and rock, a dense core wrapped in a frozen shell that has survived billions of years at the edge of the solar system. This composition hints at a history that's been quiet on the surface, but violent in the past, shaped by collisions, gravitational tugs, and the relentless pull of the Sun's faint warmth. Dysnomia, Eris's small but intriguing satellite, adds another layer of mystery. Orbiting at a relatively close distance, the Moon allows astronomers to calculate Eris's mass with remarkable precision. By tracking Dysnomia's orbit, scientists can determine how heavy the dwarf planet is, and when combined with measurements of its size, they can estimate its density. These calculations confirm what was already suspected. Eris is massive, comparable to or even slightly larger than Pluto, solidifying its place as the largest known dwarf planet in our solar system. The presence of Dysnomia also nods to mythology in a way that mirrors science. Named after the daughter of Eris, the goddess of strife, the moon embodies the theme of hidden complexity, a subtle, almost ghostly companion that quietly orbits the shining surface of its parent, yet holds the key to understanding the planet's true nature. Together, Eris and Dysnomia are more than just points of light in the sky. They are a system that forces astronomers to rethink the outer reaches of the solar system, highlighting how much remains unknown and how even small discoveries can dramatically reshape our cosmic perspective. And yet, even with all these measurements and observations, questions remain. What other surprises lurk beneath the frozen surface? How does its composition compare to other distant objects in the Kuiper Belt? Each answer seems only to open the door to more questions, reminding us that Eris is not just a scientific curiosity, but a living puzzle at the edge of human knowledge. The story of Eris's discovery reads almost like a detective thriller, full of patience, perseverance, and a touch of cosmic luck. The team at Palomar Observatory had been conducting a painstaking survey of the outer solar system since 2001, scanning vast swaths of the sky with the Samuel Ocean Telescope and the powerful Quest camera. Night after night,
the telescope captured billions of stars and galaxies, each frame carefully analyzed by computers designed to detect anything that moved. Most of the time, these automated systems found false positives, glitches, cosmic rays, or tiny background objects masquerading as something significant. But occasionally, a genuine celestial object would emerge from the data, and those were the moments that could change our understanding of the solar system forever. Finding Eris was far from straightforward. Unlike asteroids or near-Earth objects that race across the sky, Eris moved agonizingly slowly, almost imperceptibly against the star-studded background. The computers initially missed it, and it remained hidden in archived images for more than a year. It wasn't until astronomers performed a specialized reanalysis, focusing on distant, slow-moving bodies, that the object finally revealed itself. Once identified, it became immediately clear that this wasn't just another Kuiper Belt object, it was something extraordinary. The discovery process highlights just how meticulous and painstaking modern astronomy can be. For every Eris found, thousands of hours of observation, data processing, and cross-checking are required. The astronomers had to compare images frame by frame, confirm the motion, and ensure that nothing in the data could mislead them. And even after it was spotted, the team faced another challenge. They had to confirm that it was indeed a new world, not a previously cataloged object. The moment Eris was finally recognized as a distinct, massive dwarf planet marked not only a triumph of technology, but also a testament to human persistence and the painstaking craft of discovery at the very edge of our solar system. Once Eris had been spotted and confirmed, a new challenge immediately presented itself. What should this mysterious, distant world be called? In astronomy, naming a newly discovered object is never a casual process. Every new discovery receives a provisional designation, a string of letters and numbers that encode the date of discovery and its place in the catalog. In this case, the designation was 2003 UB313, a label that, while technically precise, lacked the drama and personality that such a remarkable object deserved. But moving from a provisional name to a permanent one is far from straightforward. Names are expected to follow long-standing traditions, often drawn from Greek or Roman mythology. Yet the list of available mythological names had grown remarkably thin over the centuries. Names like Persephone and Proserpina were already claimed by asteroids discovered decades or even over a century ago. Even Vulcan, the Roman god of fire, had been long reserved for a hypothetical planet closer to the sun, one that never actually existed. The challenge was clear. They needed a name that captured both the scale and the story of this extraordinary discovery. After careful consideration, the team settled on a choice that was both scientifically respectful and deeply symbolic: Eris. In Greek mythology, Eris is the goddess of strife and discord, the figure who, according to legend, sparked conflicts among gods and mortals alike, culminating in events like the Trojan War. The name was almost poetic in its accuracy, because this icy, distant dwarf planet had already caused enormous upheaval within the astronomical community. Its discovery forced decades of assumptions about planetary classification into question, sparked global debates over Pluto's status, and ignited intense discussions about the very definition of a planet. In one sense, the name Eris felt like a reflection of the chaos the object had caused, a frozen mirror of discord and upheaval at the edge of our solar system. The small moon orbiting Eris, meanwhile, was given the name Dysnomia, after Eris's daughter, the demon spirit of lawlessness. Dysnomia's naming was clever in its subtlety, a nod to the controversies surrounding both the dwarf planet itself and the process of its discovery, yet also consistent with the mythological theme. Over time, astronomers and the public alike have come to refer to the moon simply as Di, a practical shorthand for what is otherwise a mouthful. Together, the names Eris and Dysnomia form a narrative pair, embedding a story of myth, scientific struggle, and cosmic drama into the very identity of the bodies themselves. But the naming of Eris was more than a whimsical choice. It was a statement of scientific and cultural significance. By choosing a name steeped in mythology, the discoverers were connecting the cold, distant reality of the Kuiper Belt to humanity's long-standing fascination with the heavens, blending empirical discovery with the storytelling tradition that has accompanied our observations of the night sky for millennia. In a way, the names transformed Eris from a simple point of light in the darkness into a character with a story, a world with a personality, and a symbol of the profound challenges that arise when new discoveries confront established knowledge. Even now, Eris and Dysnomia carry layers of meaning far beyond their letters. They are reminders that discovery is never just about data points or measurements. It's about narrative, context, and the human impulse to make sense of the unknown. They represent a frozen frontier at the very edge of our solar system, a place where science and myth collide, where controversy and curiosity intertwine, and where the discovery of a single distant world has reshaped our understanding of the solar system and our place within it. The names themselves encapsulate the drama of exploration, the excitement of uncovering the unknown, and the enduring tension between tradition and discovery, all in a pair of small, celestial bodies orbiting silently in the darkness, telling a story that continues to unfold with every new observation.
Eris is more than just a distant point of light at the edge of our solar system. It is a testament to the power of discovery, the persistence of scientists, and the mysteries that still await us in the outer reaches of space. From its dramatic, highly eccentric orbit to its dazzlingly bright, frozen surface, Eris challenges our understanding of what a planet can be and forces us to rethink long-held definitions. Its discovery reshaped not only the classification of Pluto, but also how we approach the study of distant worlds, highlighting the delicate balance between careful scientific process and the excitement of making history. Beyond the science, Eris tells a story about humanity itself, our desire to explore, to name, to understand, and even to argue over the meaning of the discoveries we make. Its tiny moon dysnomia, its reflective white surface, and its extreme orbital cycles remind us that even at the farthest reaches of our solar system, worlds exist that are dynamic, surprising, and full of untold stories. As astronomers continue to observe Eris and search for other hidden objects in the Kuiper Belt, each revelation brings us closer to a more complete understanding of our cosmic neighborhood. Ultimately, Eris stands as a symbol of both the known and the unknown. It is a world of extremes, of mystery, and of enduring fascination. A frozen, distant, and brilliant reminder that the universe is far larger and more complex than we can fully grasp. And while we may have answers about its size, orbit, and surface, Eris still leaves us with questions. What other surprises lie hidden beyond the planets we know, waiting for the next generation of explorers to uncover? The story of Eris is far from over. It is only just beginning.